Hello everyone, good morning. Welcome back to our physics class. We have completed unit 1 electrostatics. I think you have watched all the videos and you may have learned. Let me recall the topics we have discussed in the first unit. Then we can discuss the book back question answers. So unit 1 electrostatics, that is study of charges at rest. That we have learnt point charge, Coulomb's law and electric dipole. Okay. Then continuation of the Coulomb's law, we have learned electric field, electric potential, E and V. Electric field due to dipole, electric field due to dipole on axial line, equatorial line, similar electric potential due to dipole we have discussed. Then from electric field, the explanation extends to electric flux and Gauss law. From electric potential, the explanation we have extended to electric potential energy. After that, we have discussed about electrostatic conductors. Okay, electrostatic conductors. Then Gauss law also we have discussed with a long charged wire, plain sheet of charge, spherical shell and all. Then electrostatic conductors. First we have discussed about capacitor series parallel, and capacitors with dielectric medium, also capacitor without dielectric material. Then another one, conductor, that is generator we have discussed, that is Van de Graaff generator also we have discussed. This is based on the action at points, lightning arrestor and Van de Graaff generator. So these topics we have covered in the first unit. Alright students, in this first unit, objective type questions I am not discussing you. I will discuss later. In today's video, we can discuss only the short answers and long answers. 2 marks, 3 marks and 5 marks. I have the old edition book. Sometimes the page number may have little change. So, note it properly. Let's see that. Short answer questions. First one, what is meant by quantization of charges? That is in page number 4. Okay. Listen here. In page number 4, under the heading of quantization of charge, the charge Q of any object is equal to integral multiple of this fundamental unit of charge E, Q equal to NA, where N is an integer. This is called quantization of charge, where E is known as the charge of electron. Okay, so this is first question. The next question is, write down Coulomb's law in vector form and mention what each term represents. That also in the same page, page number 4. Listen, according to Coulomb, under the Coulomb's law heading, Coulomb, the force on the point charge Q1, Q2 exerted by the another point charge Q1 is, you have to write this equation. Then you have to explain what each term represents. R1 2 cap is a unit vector directed from charge Q1 to Q2 and K is a proportionality constant. Okay, this is the question 2. This question actually they asked to represent the vector form and mention what each term represents. But sometimes if they asked Coulomb's law state Coulomb's law. For that you can write this first point under the important aspects of Coulomb's law. Coulomb's law states that electrostatic force is directly proportional to the product of the magnitude of 2 point charges and inversely proportional to the square of the distance between the 2 point charges. This is the statement of Coulomb's law. Clear? The next question is, what are the differences between Coulomb force and gravitational force? This is in page number 5. Listen, under the important aspects of Coulomb's law, the last point is the answer for this question. Okay, Coulomb's law has same structure for Newton's law of gravitation, and the 6th point has various sub-points also. that we can write by means of putting two columns. One side gravitational force, the other side Coulomb force. So actually you have to mention from this point to this point. This they can ask for 3 mark question. Okay, this is question number 3. So when you put the two columns, one side gravitational force, the other side Coulomb force, means you can write gravitational force between the two masses is always attractive. This side it is attractive and Coulomb force always repulsive. Then you can write the G value here and K value there, and electrostatic force is greater than magnitude and gravitational force is smaller. Then it is independent of medium. It depends on the nature of medium. Then gravitational force is same whether it is rest or motion, but Lorentz, when the charges are in motion, in addition to Coulomb force, Lorentz force also will exist. So these are the points you have to note it for question number 3. The differences between Coulomb force and gravitational force. Okay, that is in page number 5. You can put two column and you can write the two forces. And you can add one more point. Electrostatic force is directly proportional to the product of, this gravitational force is directly proportional to the product of two masses, but Coulomb force is directly proportional to the product of two charges. Here itself start. The electrostatic force is directly proportional to the product of magnitude of charges, and the gravitational force directly proportional product of two masses. Okay, so these are the points you have to write for the differences between differences between gravitational force and Coulomb force. The next question is, write a short note on superposition principle. This is in page number 9. So in page number 9, under the superposition principle heading, according to this principle, you can start from here. Question number 4, according to superposition principle, the total force acting on a given charge is equal to vector sum of forces exerted by on it or other charges. If they ask only superposition principle, you can write this much, but they will be asking to explain, so you have to write from here to and at last. That is till here. Okay, this is equation 4. This can be asked for 3 mark question. The next question is, define electric field. This is in page number 12. Page number 12. The electric field at the point P at a distance r from the point charge Q is the force experienced by the unit charge and is given by E equal to F by Q0. R cap is a unit vector pointing from Q, and the electric field is a vector quantity. SI unit of electric field is Newton per Coulomb. Okay, so this is question number 5. Define electric field. You have to write with the unit also. Understand? The next question is, what is meant by electric field lines? 6th question. What is meant by electric field lines? This is in page number 18. Page number 18. Electric field lines. They form a set of continuous lines which are the visual representation of the electric field in some of the region of space. Okay. So from here to here, this is the answer for 6th question. Understand? What is electric field lines? The next question is, the electric field lines never intersect. Justify. The electric field lines never intersect. Justify. This is in page number 20. So in page number 20, under the heading of electric field lines, before the last point, no two electric field lines intersect with each other if two lines are crossed at a point. From here to here, till this point ends. So this is the answer for 7th question. Okay, this is also frequently asked question. The next question is, define electric dipole. page number 21. Define electric dipole. All the short answers are very important short answers. Even though some questions are in the book back, all the topics, all the pages you have to learn. Okay. Here page number 21. Electric dipole. Two equal and opposite charges are separated by a small distance called an electric dipole. You can learn the examples also. Carbon monoxide, water, ammonia, HCl, etc. Okay. So this is question number 8. The next question is, what is the general definition of electric dipole moment? This answer is actually not directly given in your book. What is the general definition of electric dipole moment? It is in page number 21. Here, the electric dipole moment is defined as P vector equal to QR plus vector minus QR minus vector, where R plus is the position vector from plus Q from the origin and R minus is the position vector of minus Q from the origin. Actually, you can write in sentences, the electric dipole moment is defined as the product of charge and the separation between the two charges. Okay, P vector, we know that P vector equal to 2AQ cap, 2AQ into P cap, 2AQ into P cap. So this is the product of one of the charge and the separation between the distance. Such a way you can write. So what is the general definition of electric dipole moment? It is defined as the product of, you can note it, product of one of the charge and the separation between the two charges. So P vector equal to 2AQ into P cap. Okay. So what is the unit of dipole moment? Charge unit is coulomb and distance is meter. So unit of dipole moment is coulomb meter. The next question is, define electrostatic potential. Define electrostatic potential. That is in page number 28. So in page number 28, electric potential, that is under the heading of electrostatic potential and electrostatic potential energy. In that, the electric potential at a point P is equal to the work done by an external force to bring the positive charge from here to here. So question number 10. Okay. The next question is, what is equipotential surface? What is an equipotential surface? This is in page number 32. Page number 32, an equipotential surface is a surface on which all the points are at the same potential. All the points are at the same potential. So this is question number 11. Short definitions means it will be 2 more questions. Little explanation is there for 3 more questions. Okay. Then next question is 12th question. What are the properties of an equipotential surface? That is in page number 33. Listen, here properties of an equipotential surface. So 2 points are given. This is question number 12. Okay. Next question is, give the relation between electric field and electric potential. That is in page number 33 and continuation with 34. So relation between electric field and electric potential, question number 13. This page, and you have to continue with the next page. That is till here. Or else you can write this also. Question number 13. The next question is, define electrostatic potential energy. Electrostatic potential energy. This is in page number 36. that answer is actually in page number 34 and 35. Okay, not 36. That it starts from, if the charge Q2 is brought from infinity to the point at a distance r from Q1, the work done is the product of Q2 and electric potential is W equal to Q2V, and this work done is stored as electrostatic potential energy. Okay, so thus U equal to Q2V. So from here till this you have to write. Actually that answer is not directly given. This is question number 14. Okay, so the work done to bring the charge from one point to another point, that is stored as a potential energy. Okay, so potential energy means U. So this is question number 14, electrostatic potential energy. The next question is define electric flux. This is in page number 38. So page number 38, the number of electric field lines crossing a given area kept normal to electric field lines is called electric flux. Okay, this is question number 15. It's denoted by 5 and its unit is Newton meter square coulomb raised to -1. Even though it did not ask about the unit, you should mention the unit. Sometimes the key answer may have the unit mark. Okay, so you should include the unit. If you don't know the unit, just leave it. If you know the unit, you write it. The next question is, what is meant by electrostatic energy density? What is meant by electrostatic energy density? This is in page number 58. Actually, you have to know where V is the potential, V is the potential, U is the energy, and small u is energy density. Okay. So page number 58, somewhat the answer is clear. That is, the energy stored per unit volume of space is defined as the energy density. This is question number 16. The energy stored per unit volume is defined as the energy density. Question number 16. Clear? The next question is, write a short note on electrostatic shielding. That is in page number 50. Write a very important question. Write a short note on electrostatic shielding. So under electrostatic shielding heading, you have to write. You don't want to write full points. Important points alone you can write. That is, the electric field inside the hollow and solid conductor is 0 from here to. The electric field inside the question number 17. Okay, the electric field inside the hollow and solid conductors is 0. Then you can explain this one. Okay, and you can write this also. So page number 50, a big answer is there. You can short and write. The main point in this electrostatic shielding is the electric field inside the conductor is 0. Okay, electric field inside the conductor is 0. That is the main point. This paragraph actually a separate question. They may ask why it is safer to sit inside the car during lightning. So for that also this question you can write. So this is question number 17. Write short notes on electrostatic shielding. Those who can, you can write everything. Okay. The next question is, what is polarization? That is in page number 54. So polarization is defined as the total electric dipole moment per unit volume of the dielectric. This is question number 18. Okay. This also you can write. This is enough. The next question, question number 19. What is dielectric strength? Page number 55. So dielectric strength. This is okay. The maximum field, actually the maximum field of the dielectric can withstand before breakdown is called dielectric strength. This is question number 19. If they ask for 2 marks, you can write from here also. Okay, question number 19. The next question is define capacitance, give its units. Question number 20, page number 56. So, capacitance, its unit also you have to mention. Okay, so this is question number 20. Next, question number 21. What is corona discharge? This already I have given the short definition. Otherwise, you can write in the page number 67 answer. So here, from smaller the radius, or you can write this one from here. What is corona discharge? Consider irregular shape of conductor. Otherwise, till this you have to write 21. Okay, you have to explain from here to here. Otherwise, you can write in a short method. Diagrams and all don't want. Shortly, you can write the leakage of conductor. Sorry, the leakage of charges around the sharp edges of the conductor is known as electrostatic. Action at points or corona discharge. The leakage of charges around the sharp edges of the conductor is known as action at points or corona discharge. So these are the short answers. Now let's move on to the long answer. That is, first question, discuss the basic properties of electric charges. Page number 3. This they can ask for 3 more questions, not 5 more questions. Okay. So first question, basic properties of charges. 3 headings are there. You can short and write. This they can ask for 3 more questions. First point, electric charge from here to, you can write till here. And next point, conservation of charges. That is total charge, this definition. From here to the next page till here, and quantization of charge. Okay, from here to here. So this is long answer. The long answer I have marked with another color pen. Understand? The next question. Explain in detail Coulomb's law and its various aspects. This is in page number 4. So in page number 4, Coulomb's law is there. You can write the Coulomb's law, then important aspects of Coulomb's law. This is long answer 2. Okay, important aspects of Coulomb's law. 6 points are there, that also you can short and write. Okay, from here to till, 7 points are there. Till here. Okay, this is long answer 2. The important points alone you can note it. The next question is define electric field and discuss its various aspects. That is in page number 12. So page number 12, define electric field, the important aspects. Long answer 3. So here the diagrams and all not necessary, just the points alone you can write, short and write. So till this, long answer 3. Okay, you can specify the important notes alone. Next question, how do we determine the electric field due to a continuous charge distribution? Explain. That is in page number 16. This may not be there for the new book. Anyway, it is in page number 16. That is electric field due to continuous charge distribution. Okay, question number 4. You can start from here and it ends this till this. Okay, I think in the new edition this question was deleted. Anyway, this is the answer. The diagrams you have to draw. Next question is very important question. Calculate the electric field due to dipole on its axial line and equatorial line. Actually, these two questions are, this question, they can ask two different questions. One is axial line and another one is equatorial plane. Okay, this is in page number 23. Very important question and frequently asked question. So page number 23, first one axial line, that is from here to question number 5. From here to the diagram is very important diagram. Draw carefully from here to till this 2p by r cube. Question number 5. And equatorial plane is this one, that is from here, question number 5, here to till this diagram. Two diagram also you have to draw. Okay, important inferences and all don't want. The next question is, derive an expression for the torque experienced by a dipole due to a uniform electric field. This is in page number 24. This also they can ask for 3 mark question, not 5 mark question. So this is the answer. Question number 6, from here to next page. That is till here. Okay, question number 6. Next question is, derive an expression for electrostatic potential due to a point charge. Page number 28. You can take the screenshot, the page number, and you can note also. Page number 28. So electric field due to a point charge from here to here. Okay. The next question is, derive an expression for electrostatic potential due to an electric dipole. This is in page number 30. This is also a very important question. That is from here. Question number 8. From here to next page. Fully you have to write till this, till the special cases. Next question. Obtain expression for potential energy due to a collection of 3 point charges which are separated by finite distance. This is in page number 34. 3 charges are arranged in the following. From here, question number 9. From here to till this, including this diagram. Okay. Are you able to note it? The next question. That is, derive an expression for electrostatic potential energy of the dipole in the uniform electric field. This is in page number 36. First one, potential energy due to collection of 3 point charges. This is actually these questions and all they can ask for 3 mark question. Okay. Derive an expression in electrostatic potential energy of the dipole in the uniform electric field. That is in page number 36. This one. Question number 10. From here to the next page. That is till here. Okay, question number 10. I can write till this also I can write. Okay, that is this is explaining about the special cases. Next question is, obtain Gauss law from Coulomb's law. Obtain Gauss law from Coulomb's law. That is in page number 40. That is Gauss law heading. From here, this is question number 11. From here to till this 11. Okay, this is obtain Gauss law from Coulomb's law. Next, obtain, very important question, obtain an expression for the electric field due to infinitely long charged wire. That is in page number 43. Actually what I have marked as a tick mark in this side, that and all very important questions. Okay, so electric field due to infinitely long charged wire, that is in page number 43. From here, that is question number 12. You don't want to draw this diagram and all. From here to fully this, next till this. Question number 12. You have to draw only this diagram. Understand? Okay, you can move on to the next question. Obtain expression for electric field due to infinitely charged infinite plane sheet. This is page number 44. And the same, the next question. Obtain expression for the electric field due to infinitely charged spherical shell. This is page number 46. Actually, these all are the applications of Gauss law. Okay. First application is the 12th question. 13 and 14 the questions are the next applications. So, page number 44 and 46. Electric field due to infinitely charged plane sheet. So, this is question number 30. From here to till sigma by 2 epsilon 0. Okay. In vector form, if you want, this also you can write. So, this is question number 30. Next, due to spherical shell. So, this is question number 14. Spherical shell. From here to next, spherical shell at a point outside the shell, at the surface of the shell, and next at a point inside the spherical shell. Okay. So, till this. This is question number 14. Next question, question number 15. Discuss the various properties of conductors in electrostatic equilibrium. That is in page number 48. So, this is the question. Electrostatic conductors and dielectrics. So, properties. These are the properties. Question number 15. First property, second property, third property. You can write shortly. Fourth property. Okay. So, till this question number 15. Understand? And next question is, explain the process of electrostatic induction. That is page number 51. So, page number 51, electrostatic induction heading from here. So, question number 16, from here to till this end. Okay. Next question is, explain in details and how an electric field is induced in a dielectric. How an electric field is induced in a dielectric. That is in page number 54. So, induced electric field inside the dielectric. So, from here to till this. This is example. Don't want at least till this you have to write. So, question number, I think 17. Okay. Next question. Obtain expression for capacitance for a parallel plate capacitor. Very important question. Page number 56. Capacitance of a parallel plate capacitor. Question number 18. Okay. Long answer. From very important question. This till this you can write. Question number 18. Those who can, you can write this conclusions also. Capacitance of a parallel plate capacitor. Next question. Obtain the expression for energy stored in the parallel plate capacitor. That is in page number 58. Question number 19. So, energy stored in the capacitor. Question number 19. From here to, actually till this only energy. This is energy density. You can add this also. So, this is question number 19. Okay. Next question. Explain detail the effect of dielectric placed in the parallel plate capacitor. That is in page number 59. Effect of dielectrics in capacitor. Okay. So, question number 20. From here. This also you have to write very shortly. Everything is there till this. Okay. Question number 20. Effect of dielectric in capacitor. when the battery is removed and when the battery is connected. Next question. Derive an expression for resultant capacitance when capacitors are connected in series and parallel. This is on page number 62. Very important question. Capacitors in series and parallel from here. That is question number 21, I think. From here, series till this much and parallel. Next page, till this much. Okay. Next question, explain in detail how charges are distributed in a conductor and principle behind lightning conductor. That is page number 65 and 66. That is distribution of charges in a conductor. So this is question number 22 from here to till this. And also they asked lightning arrestor or lightning conductor. So this also you have to include from here. Lightning arrestor or lightning conductor from here to next page till this. Okay. And the last question is explain in detail the construction and working of a Van de Graaff generator. So that is in page number 68. Okay, very important question. So you have to draw this diagram. Question number 23 from here to till this. Okay. Alright friends. In this long answer, not all the questions are 5-mark question. Anyway, you have to learn very importantly axial and equatorial line and this torque, this and all 3-mark question. Electric potential due to dipole, 8th question. Then expression for electric field due to infinite long charged wire, and capacitance of a parallel plate capacitor. This is 3 marks sometimes. Energy stored in the capacitor, 3 mark, and 5 mark is capacitance series parallel. Then at last Van de Graaff generator. These are the very important questions and frequently asked questions. Okay students, mark the answers and learn well. Thank you for watching.